Hi, this is the fourth video in the series on plane geometry. In this video, we'll discuss two important concepts in geometry, those of area and perimeter. Let's first recall what we discussed so far. We only discussed one shape, triangle. And a triangle is something, as its name suggests, it has three angles. And we said we use uppercase letters to denote the angles. The angles are also called vertices. Each point is called a vertex. The plural is vertices. So you use uppercase letters to denote the angles or vertices, and lowercase letters opposite to the angles are then used to denote the sides. And one other thing we learned about any triangle is that if you measure all the internal angles using a protractor, then they add up to 180 degrees. This is true about every triangle. So angle A plus angle B plus angle C is 180 degrees. Now the side lengths don't have any such property, but angles always add up to 180 degrees. Now triangles are the simplest figures in a class of shapes called polygons. And what is a polygon? A polygon is something that is closed and is made of straight line segments. And triangle is the simplest one. If you have only two sides, you cannot form a closed shape. And if the sides forming the closed shape is curved, then it's not going to be a polygon. So what are some non-examples? Let's write down some non-examples of polygons. So how can something fail to be a polygon? If the shape is not closed. So say you have this shape. So this is not a polygon because it's not closed. Or sometimes what you may have is that one of the sides is curved, something like that. So this is also not a polygon, because this is not a polygon even though it's closed, because one of the sides is not formed from a straight line segment, but it's formed from a curved line. Now, triangle is the simplest of all the polygons. It has three sides. Each of the sides is a straight line segment, and also it's closed. Now, if you have not three but four sides, so this time let's try to draw a shape that has four sides. So four sides, and also make it closed. So this is a polygon, and this time I'm going to use four letters, A, B, C, D. Now, a four-sided shape is called a quadrilateral. Quad means four and lateral means side. So a quadrilateral has now four angles and four sides. Here is one important piece of information. You can draw a straight line segment from one of the angles to some other. So let's say in this shape I can connect B and D. So this line segment lies completely inside the triangle, inside the quadrilateral, and is called diagonal. So a line that stays completely inside a shape and which connects two vertices is called a diagonal. Now I cannot call BC as a diagonal because it does not stay inside the shape. So there's one diagonal and there is another diagonal. So I could have connected A and C. So that would give me two diagonals. But let's just draw one diagonal and notice what is the sum of all of the internal angles. If you try to add them all up, what you have noticed is that diagonal BD has split the internal angles into two parts. So this is, so you get two triangles, and each triangle has a total angle of 180 degrees. And notice the angle B is got split and the angle D is got split. So angle A plus angle B plus angle C plus angle D should be the sum of the angles of this triangle ABD and the sum of the angles of this triangle BCD. So it should be 2 times 180 degrees is equal to 360 degrees. And that's going to be useful information when we discuss different quadrilaterals next. So now this is a general quadrilateral. I want to start with something that is extremely special. So let's draw a shape. Let's draw a quadrilateral where all of the sides are equal. Notice AB and AD are not equal here, but I'm going to draw all sides equal, and also all of the angles I want them to be equal. So if I'm drawing a shape with equal sides A, B, C, D, what I'm saying is all of these side lengths are equal. And if all of the angles are equal, then each angle should be a quarter of 360. So that has to be 90 degrees, because when you divide 360 by 4, you get 90. So that means all of these angles will be 90 degrees. All right, so this shape is called a square. Now let's draw another quadrilateral where we don't have such a nice quality, but we have most of the qualities there. So this time what I'm going to do is I'm going to make two of the sides longer. So it's not a square anymore, but it has the other properties. So AD is still equal to BC and AB is equal to CD. But notice AD and AB are not equal. So I'm going to use double tick marks to denote that. And let me keep the angles also equal. And so each angle would have to be 90 degrees. So this is called a rectangle. So we are trying to draw all the whatever quadrilaterals we can draw. So first we drew square, then we drew rectangle. Now what I'm going to do is I'm going to mess with this rectangle a little bit so that the angles are no longer 90 degrees. So the side AD is tilted and so is BC tilted, and they are tilted by the same amount. So A, B, C, D, and still AD is equal to BC and AB is equal to DC. But notice I'm not drawing 90 degrees angles here. And this shape is called a parallelogram. So you have two pairs of parallel sides. So parallelogram. So we drew three shapes: square, rectangle, and a parallelogram. Now let's modify the parallelogram a little bit so that now you don't have equal lengths. So say I have something like that. So, oh, by the way, one other property is that the opposite sides in all the previous shapes are going to be parallel. So you will have this property. So let's use single arrow to denote that these two are parallel, double arrow to denote that these two are parallel. So we can do that here as well. So AB and CD are parallel, and so are AD and BC. Similarly, you could do that. These two are parallel and so are these two. So you have two pairs of parallel sides. Now what I'm going to do in this new shape is keep one of the sides parallel. But notice these two are not parallel, and again I cannot say that any of the two sides are equal in length. So this shape is called a trapezoid. That's a trapezoid. Now let's modify the square a little bit. So what I'm going to do now is keep all the side lengths same, just as in square, but tilt two of the sides by the same amount. So all of the side lengths are same, so we can use those tick marks, and then opposite sides are again going to be parallel, just like in a parallelogram. But in a general parallelogram, you don't have equality of all side lengths, just the opposite sides are equal. But if you look at adjacent sides, they don't have to be equal in a parallelogram. Whereas in this shape, all of the side lengths are equal. So this is a special kind of parallelogram. This is called a rhombus. Then there is one other shape that I would like to draw, where the adjacent sides, I want to keep them equal. So say this is A, we didn't label them here. And for here, let's say A, B, C, D. So notice AB and AD, they are right next to each other. Sides like that are called adjacent sides. And what I have done is I have drawn them equal to each other. So I'm going to use single tick marks. And similarly, BC and PD are adjacent sides and they are equal in length. And this shape is called kite because it resembles a kite. So these are some of the quadrilaterals. And in general, a quadrilateral may not fit into any of these classes. You may have a general quadrilateral where none of these nice properties hold, except the fact that all of the internal angles will add up to 360 degrees, because all of the internal angles of a quadrilateral could be split into two triangles, and those internal angles of the quadrilateral are the sum of the angles in two separate triangles. So that's why it's going to be 360 degrees. Now let's come back to the main topic of this video, which is area and perimeter. And having a stack of examples of shapes will help us understand the concepts a little bit better. Now let's talk about perimeter first. So perimeter is nothing but the outer boundary of any shape, outer boundary. And since we are discussing polygons, let's say outer boundary of a polygon. So for a triangle, what would that be? If you have a triangle ABC and you're using lowercase a, b, and c to denote the side lengths, then outer boundary just means if you start walking at some vertex, walk along the triangle, so go to BC first, then go to CA, and then go to AB, and you end up here. Then the amount of distance you traveled is going to be A plus B plus C. So it's the sum of the side lengths. That's the perimeter. Now one thing to note about perimeter is it will have the same units as the units of length. So if you are measuring BC in inches and all of these are in inches, then inch plus inch plus inch is also going to be inches. So when you have something like that, you say it's one dimensional. Now, what is the area? Area informally is simply how much room you have inside the shape. So let's say the amount of room inside the shape. So how do we tell how much room we have inside the shape? Well, for a triangle, it might be a little bit hard, but if you decide to call a square, let's say this is a square, so let's talk about area of a square first. So say you have a square, and since all the sides are equal in length, so say this is 1 inch, and so is this 1 inch. Then the area inside is called 1 square inch. And let's look at area of a rectangle with different side lengths. So say this is 5 inches and this is 3 inches, which means you can split this dimension, this side, into 3 equal parts, and each would be 1 inch. And here you could split into 5 equal parts, and each would again be 1 inch. Oh, I have not drawn to scale. You can use your imagination. Or maybe I could just say that this is 6 inches. It looks more like 6 inches. So 1, 2, 3, 4, 5, 6. And notice that the amount of room you have is given by simply adding up all these smaller squares inside. So this is going to be 1, 2, 3, 4, 5, 6, and then again 6 here and 6 again. So you're getting 6 times 3 equal to 18 square inches. And so you're multiplying. Now notice, I could have simply, without drawing all of this, I could have simply multiplied these two dimensions. And then we can develop a formula for area of a rectangle. So if you use the letters to denote the dimensions, so a rectangle has two dimensions. One is called length, the other is called width. Sometimes you use height, it does not matter. The important thing is area is given by L times W. You're multiplying these two dimensions. And since you are multiplying two dimensions, your units are not inches anymore, they are going to be square inches. So square means to the power 2. So this is a two-dimensional quantity. So area is one-dimensional, perimeter is one-dimensional, area is two-dimensional. And we found a formula for area of a rectangle by using this concept, by using that of a square. So now let's talk about area of a square in general. So if you don't have 1 inch but some other side length, so let's say this is S, then what is its area going to be? Well, a square is nothing but a special rectangle. So I can multiply these two dimensions again. S times S is S square. So we found the formula for area of a rectangle and area of a square. Now, if you want to find area of a triangle, you may want to first start with not a general triangle, but maybe a right triangle. Then let's say this is your right triangle. So this is the right angle. And instead of length and width, we use these letters for a triangle. Uh, Actually, let me not label these vertices. So let's just say that this is B and this is H. B for base and H for height. So I'm interested in knowing how much room I have inside this triangle. So you cannot fit squares inside the shape, but what you notice is that you could imagine this triangle to be part of a rectangle, and notice that you have these two areas are going to be equal. So the area of this triangle will be half of the area of that rectangle. I think we'll stop in this video. I just wanted to introduce the concepts of area and perimeter for polygons. In the next one, we will begin with finding areas of shapes that are not squares or rectangles, but we may have to do some imagination and some additional drawing to figure out the area of those shapes.